Simply with the help of four quantum numbers, we are trying to explain the structure of an atom. Right? What is actually meant by structure of atom? That how the atoms within that atoms around the nucleus, that electrons arrangement, how they are distributed, how they are moving, right? Where we need to locate that. Is it having the fixed boundary, etc. Right? So what happens when energy levels are changing, right? So everything will be discussed by the structure of atom. So we learned about that structure. So simply what we decided, now the electrons are distributed in the different shells. What that shell's shape? It is elliptical orbit. So in the elliptical orbits, they are revolving around the nucleus. They are revolving around the nucleus. So here that revolving, that is not enough to discuss. So here, all the electrons are distributed into the same elliptical orbit? No, that also we decided, right? So different energy levels are there. The different energy levels has sub-energy levels. They are only named as here subshells called orbitals, location of electron. Right? In that also again, degenerate orbitals with the help of quantum numbers. Right? So in that, how to arrange them in the degenerate orbitals. So that with the help of spin. Right? So all them we discussed. But here, how to distribute that electrons? Okay, we know that the distribution of electrons decided, but how to distribute electrons? So that will be discussed in the electronic configuration. So spin quantum number given by Uhlenbeck and Gauss-Smith, they are explained the orientation of electron within the orbital with the clockwise and anti-clockwise spin. So plus half, minus half, they are also denoted by the upward and downward arrows within the degenerate orbital. So we have set of quantum numbers. With the help of four quantum numbers, we need to distribute the electrons now. So that is only here called as electronic configuration. So in the electronic configuration, what we are doing, just we are simply distributing the electrons, arranging the electrons into the main energy levels, sub-energy levels, and degenerate orbitals. Right? So using the quantum numbers. So here arrangement of electrons in the space around the nucleus in an atom is known as electron configuration. Right? So atom consists nucleus. So nucleus only consisting protons, positive charge, and other particles. Then what about the electrons? They are only outside the nucleus within the atom. That electrons distributed, arranged into the different energy levels called as shells, KLMN. Within the shells also we have sub-energy levels, ICE, SPDF, right? That already explained by the quantum numbers. Then in the sub-energy levels, again we have within the orbitals, degenerate orbitals, right? That are explained by ML. Then into that sub-energy level, especially in the degenerate orbital, how many electrons are filled? That will be explained by spin quantum number, right? So using that quantum numbers, now I'm going to arrange the electrons into the space around the nucleus, or I'm able to define this electronic configuration in another manner, that which is here distribution of electrons into the shells and subshells, right? Mainly into the orbitals, mainly into the orbitals in an atom. That is called as electronic configuration. So now, how to write that electronic configuration will be given by a simple notation, shorthand notation we can call it as, that is here NLX method. So here electronic configuration represented by NLX method. This is called as shorthand method. Okay, NLX method is suggested. Here what is N, what is L, what is X? Here already we know what is N, what is L. N is principal quantum number and L is azimuthal quantum number. It has two more names also. Okay, whatever it may be. N is principal quantum number. L is azimuthal quantum number. And what about X? So here, within the subshell, angular momentum quantum number or azimuthal quantum number, giving you idea about the sub-energy level called orbital. So within the orbital, the number of electrons are present in it denoted by the letter X here. So X denotes the number of electrons in the orbital. So we have three things in shorthand method. What they are? N, L, X. Principal quantum number called main energy level or called shell. Then L, azimuthal quantum number is given as sub-energy level called orbital. Then finally, number of electrons distribution into that sub-shell will be given with the X. Right? So this is shorthand method. So using this, now we are trying to write the first element having only one electron. That is what here, hydrogen. So now I try to write the hydrogen electronic configuration with the atomic number Z equal to 1. That means number of protons or number of electrons count is equal to 1. Right? So here I know atomic number. Using that NLX, I am representing that as 1s1 because the first energy level will give you value 1. Principal quantum number K shell N equal to 1. Right? Then sub-energy level, if N equal to 1, what about the least possibility value for L? So N equal to 1, L will take 0 to N minus 1 values, right? Based on that. So N equal to 1, only one possibility is there. That is L equal to 0. Maximum value N minus 1 equal to 0. So only one value is possible. If L equal to 0, then we'll take sub-energy level as yes. So with the principal quantum number N, only the possibility is yes. There is no other possibility because L is taking only one value, 0. So that's why I am written 1s. The number of electrons, Z has only 1. That means atomic number of hydrogen, Z equal to 1. So 1 is the X. L is yes. N is 1. So I decided. So that's why I am written the configuration as 1s1. So here 1 is representing principal quantum number, main shell. L is representing, so here it is S, angular momentum quantum number represented by S, subshell or orbital. Then 1 representing the number of electrons in the orbital S. Have you got clarity? How I am written using that NLX method? Yes. So is it clear, everyone? Give me yes. So now, can you write electronic configuration of helium? Can anybody? Just raise your hand if you want to write. I'll give you access. Raise your hand, please. Oh. So here I am trying to write electronic configuration using this NLX method for the atom, right? For the atom, hydrogen, right? Here, I will represent you 4 quantum numbers for hydrogen only. Then I will ask you about the next element. So here 4 set of quantum numbers of hydrogen or will be like this. So n equal to 1 here because the principal quantum number is 1. So n equal to 1. Azimuthal quantum or angular momentum or orbital quantum number L equal to maximum possibility is n minus 1. So here it is n minus 1, 1 minus 1, it is 0. Sir, if it is n equal to 2, what you will take, sir? Right? So every possibility I will think. So I'll go with the least value 0 first, then maximum value 2 minus 1, 1. So like that. So here L equal to 0. Then what about ML equal to? Only one possibility is there. How would I calculate? By using the formula here. ML values is equal to 2L plus 1. 2 into 0 plus 1. That equal to only one value from the integer number set that which satisfy minus L to plus L including 0. So only the possibility is 0. Minus L to plus L, impossible. Only 0 is possible, one value. So like that, I selected ML equal to 0. Then what should I select for MS equal to? Is for the spin of the electron. According to spin quantum number, I have two possibilities. I have two possibilities. What they are here? Minus half plus half. Which shall I select here? What should be taken here? MS equal to. I have contradiction. I should go with plus half or minus half, right? So here it is a contradiction. Suppose, okay, sir, first positive, sir. Okay, I will take positive. Then I have one more doubt. Here I have helium with 2 electrons. Atomic number of helium is 2. So number of electrons present in the helium atom, 2 electrons. It has 2 electrons. So how to distribute that electrons? What should I write? Quantum numbers for the helium, right? So here, how are these 2 electrons are arranged into the S? So here, for anything, degenerate orbitals are taken with the box, a square box. So 1s1 will be written as like this. Then what about 1s2? Shall I write like this? Or shall I write like this? Or shall I write like this? Which you'll guide me to take? Which is correct among these three? 1s2, 1s2, and 1s2. Can anybody decide which is correct among these? With this knowledge, we are unable to decide. With this knowledge, we are unable to decide which method is correct. Is this one upward direction, or is this one downward direction, or this one, or one more possibility is there. That is here downward and upward. Parallel spins, anti-parallel spins. So which is correct? So I'm unable to decide. So here there is a contradiction in writing a electronic configuration by using NLX method, right? So NLX method is correct only, but to write the electronic configuration, we need to get some more information. We need to give clarification for writing the electronic configuration or to fill the electrons into the degenerate orbitals. So that is why here we are now depending on the 3 principles for the writing of electronic configuration. For writing of electronic configuration, now I am depending on the another method, that is here simply 3 principles help me to write the electronic configuration, right? So what they are here, right? They are here namely Pauli's exclusion principle, above principle, and Hund's rule. So what they suggested us? What they suggested us? So they are suggested to write the electrons or to fill the electrons, right? In writing the electronic configuration or filling the electrons into the energy levels, sub-energy levels, and into the degenerate orbitals. So we need to follow a particular method. So that methods are suggested by them. So they are only here Pauli's exclusion principle, Hund's rule, and one more is Hund's rule. Sorry. What I told you, Pauli's, above, and Hund's rule. These are the 3. So before that, here I'm giving you previous one. What I have, n equal to 1, L equal to 0, ML equal to 0. Then MS equal to plus half or minus half. Okay, you are going with plus half. Then what about in case of helium? So that we will discuss here. See here, suppose if I write a electronic configuration of helium, right? So first of all, I'll write electronic configuration of hydrogen is 1s1. Then what about helium? It is 1s2 with atomic number. But here, what should I take? M equal to, sorry, that first principal NLX method using n equal to what? 1. Here also n equal to 1. L equal to, it is s orbital. It takes 0. L equal to 0. No problem. ML equal to 2L plus 1 possibilities, only 0. ML equal to here also 0. Then what about MS? Here shall I take plus half? Here shall I take plus half? Or minus half? Or here minus half? Or opposite combinations? What should I? So here simply Pauli's exclusion principle says here hydrogen atom, helium atom must be differ in their 4 quantum numbers. At least one quantum number must be different. Right? So 4 quantum numbers are there. They must with be different quantum numbers. Maybe they are same in the first 3. Right? Principal quantum number, azimuthal quantum number, magnetic quantam number. They may same, but they must differ in their 4th quantum number. So that's why here this principle is said here. The principle is said here. It is as no 2 electrons has 4 quantum numbers, I say. So this is only principle given by him, called as Pauli's exclusion principle. No 2 electrons of the same atom, right, can have all 4 quantum numbers same. Right? So helium first electron, helium second electron. Right? So 2 electrons are not available in the hydrogen. So we are going for helium. So how to fill them in the degenerate orbital? So that is explained. Suppose if I take like this, what happens? N equal to 1, ML equal to 0, L equal to 0, and MS equal to, I am getting for the both 2 electrons plus half and plus half. So first 3 same for each electron, and last also getting same. So this not accepted by the Pauli's exclusion principle. So what to do? In this case, this method is wrong. So I'm going for the different method that is here with anti-parallel spin. Then it is satisfying. For the 2 electrons of helium, 2 electrons of helium, N equal to 1, L equal to 0, ML equal to 0. But for first electron, MS equal to plus half, and the second electron, MS equal to minus half. So this is only Pauli's exclusion principle, right? So this we need to satisfy in filling the electrons, into degenerate orbitals, right? So now look at here. No 2 electrons of the atom, same atom, have all 4 quantum numbers same. So negatively it is discussed. No 2 electrons. So 2 electrons of same atom existing with the 4 quantum numbers individually. In that 3 may same, but 4th one must be different. That is only here mean. So helium atom has 2 electrons. The first electron occupies 1s orbital. Okay, right? Then second electrons also join into the 1s orbital. So the electronic configuration of helium will be written as 1s2. But here, that electrons of helium atom, first electron, second electron, they are having the 3 as N, L, ML, may be same, but this must be differed in the spin quantum numbers, MS. So plus half, minus half, 2 possibilities there. So one possibility, first electron with positive and second electron into the same degenerate orbital with the negative value. So in the helium atom, the spin must be paired oppositely, paired with opposite spins. So plus half, minus half, right? So electrons with paired spins are denoted by upward arrow and downward arrow. Here upward arrow indicating positive spin, downward arrow indicating the negative spin. So for that, we are representing ms with plus half for the first electron, ms with the negative spin for the second electron. So they are with the anti-parallel spins. They are with the anti-parallel spins. So now we are taking here helium atom electronic configuration is followed. So what that is here into first level, that is n equal to 1 into the degenerate orbital, L equal to 0. So it goes into S orbital. So it became 1s. Then how many electrons are there with us? 2 electrons. The 2 are filled into this degenerate orbital. 1s is one is with upward arrow and the another will be with the downward arrow. So this is, we are writing electronic configuration of helium is 1s2. If you write the 4 quantum numbers for the first electron and the second electron, you are getting like this. What they are here for the first electron, first electron, I am writing 4 quantum numbers, n equal to, using NLX only, n equal to 1, L is depending on the orbital, yes it is, so L equal to 0, and here first electron I am selected, so in the same box, only one possibility is there for ML, that is 2L plus 1, according to that, minus L2 plus L, only 0 I am selected, so ML equal to 0. For second electron also, I'm writing the first 3 quantum numbers. N equal to 1, L equal to 0, and ML equal to 0. But first electron is facing upward. So MS will be with positive spin, and second electron facing downward direction minus half. Now look at 2 electrons of same atom, helium, having the 4 quantum numbers as same. No, they are not same. So this is only Pauli's exclusion principle. Right? This is only Pauli's exclusion principle. So here look at. In this, here, how many electrons? There is one more contradiction. Okay, 1s is filled. Right? I'm going for 2s. Next, I will go for 2p, like that, based on that. Here, how many electrons can occupy an orbital? There is a possibility, what that is anti-parallel spins, so only 2, right? The major consequence of that exclusion principle involves orbital's occupancy, that is given only 2 electrons, right? Only 2 electrons. Then here, the maximum number of electrons into the subshells are here given as into the subshell, yes, 2 into the subshell is 6, into the subshell D is 10, into the subshell F is 14, according to 2 into 2L plus 1 formula. So number of electrons occupying into the subshell, SPDF, given with a formula. So according to that, here how can I fill always with 2 electrons, right? So for this, what I required? Degenerate orbitals into each. So maximum capacity or maximum occupancy of orbitals are given only with 2. So that's why here we are going for another, that is into the degenerate orbital concept. Right? So here maximum occupancy into the P is given 6, but here maximum occupancy into orbital is 2. So how can I fill that 6? So I required 2 more to fill 4 more electrons. So that's why I required 3 degenerate orbitals into the P subshells. D subshell 5, F subshell 7, like this. Clear? So any confusion? Any confusion here? Let's go for quick reaction if there is any confusion. If there is confusion, so no one. Are you able to hear my voice? Okay, whatever it may be, I'm moving to the next one. Here, because of that contradiction, now electron filling order is given by the energies, right? So, Abbo suggested about energy of the orbitals. So, Abbo principle says that electron filling order based on the energy of the subshells. occupancy of orbitals by the electrons, occupancy of electrons into the orbitals, simply depending on the energies. So here we need to calculate the energies using that NLX method only. Okay. Here, as per that, here NL we are taking. So N is principal quantum number, L is azimuthal quantum number. Okay. Here I'm taking, suppose here N equal to 1. N equal to 1. What are the possibilities for L? L equal to 0 to N minus 1. That is only maximum value is 0. Then N equal to 2. L equal to 0 possible, and according to N minus 1 principle, 1 also possible. 2 minus 1. So 0 and 1. 0 and 1. N equal to 3. L equal to 0 possible. Then N minus 1. 3 minus 1. That is 2. So 1 possibility is there. 2 possibilities there. Likewise here, you need to take them. So N equal to 4, L equal to 0, 1, 2, and 3. N minus 1, 4 minus 1, maximum possibility is 3. So using these N and L, I am writing orbitals with energy levels. So 1 and 0 combination. 0 representing S orbital. So 1, yes. 2, L is 0 taking first. Yes, I will get. Then with the same N value, L equal to 1 possibility is there. So I will take here 3S, 2 and 1 is representing P. Then here N equal to 3 possibilities there. With the 3, L possibilities are 3. So 3 and 0 means yes. 3, 1 means P. 3, 1 means D. Yes, okay, correct. 2 means D. The next N equal to 4. Then S equal to 0. Yes. So L equal to 1 means 4 P. L equal to 2 means 4 D. L equal to 3 means, so 0, 1, 2, 3. If L equal to 4, maximum possibility. So N equal to 5. What will take? L equal to 0, 1, 2, 3, 4. So that is S, P, D, F, and we'll go for the next one is Z, but not there. Right? So here maximum occupancy is given. Right? So what they are here? 2 electrons into each, and F maximum takes here 14. So 10, here 6, here 2. Right? So each one box, ML values are given. ML equal to what? 2L plus 1. So according to L equal to suppose 2, L equal to suppose 2. What is ML? 2L plus 1. That equal to what? 2 to the 4 plus 1, 5. So here you are required 5 degenerate orbitals. That is only here suggested to fill 10 electrons. So ML importance is this only. Right? So it is and spatial orientation. So 0, minus 1, minus 2, plus 1, plus 2, like this arranging. So each degenerate orbital assigned with a address called ML value, minus 2, minus 1, 0, plus 1, plus 2, like this. So using them, you are now writing or describing the energies. That is here using N plus L values. Energy calculated in terms of N plus L values. So N is principal quantum number, L is azimuthal quantum number. Suppose here, according to N possibilities, N equal to 1 is there, N equal to 1 is there, L equal to 0 possible. So N plus L value is equal to what? 1 we are getting. So 1s. Next, I'll go for N equal to 2, L equal to 0 possibility is there. And with the same N equal to 2, L equal to 1 possibility is there. So N equal to 2, L equal to 0, that is 2s. Then N equal to 2, L equal to 1, that is 2p. Right? So N plus L values are 2 plus 0. Here for 1s, I am getting 1 plus 0 is 1. its energy, N plus L values here. Right? For 2s, 2 plus 0, I'm getting 2. Then 2p, 2 plus 1, I'm getting 3. Then N equal to 3 possibility here. So L equal to 0 possible, L equal to 1 possible, L equal to 2 possible. So with this combination, here what I can write? 3 and 0 means yes, 3s. Okay. For 3s, N plus L value is 3. Right? Then after 3s, 3 and 1 combination. So 3 and 1 combination giving you 3p. So for 3p, what N plus L value I can assign here? N plus L value is assigned. 3 plus 1 is 4. Right? The next, I'm going for 3 plus 2 combination here. So 3, 2. 3, 2 is SPD. So 3D. Its N plus L value is 3 plus 2, 5. Likewise, you can calculate N plus 2L. So N equal to 4. L possibility is 0. L possibility is 1. L possibility is 2. And L possibility is 3. So each combination, N and L, according to that, N equal to 4, L equal to 0 means yes, 4s orbital. Next, 4s after 4 and 1. 1 is P. Next, with the 4 combination only, principal quantum number 4 and 2 is 0, 1, 2, SPD. So next, 4f like this. Then here, writing N plus L values. So 4 plus 0, 4 only. 4 plus 1, 5. 4 plus 2, 6. 4 plus 3, 7. So I am able to get a N plus L values here, encircled. Right? They are encircled here. So look at them. Are they in the same manner in increasing order? No, there is a disturbance here. There is a disturbance. So for this, Abbo suggested us, right? In such cases, you need to follow one logic method. Right? There is a logic method. So here is 4, here is 4, here is 5, here is 5. So in this cases, what to do? Right? What to do? Are you clear in this explanation? How I got that N plus L values? Everyone, give me your response. Is it clear how I calculated N plus L values? So using that same, what we learned, NLX method. From that I calculated, I am written. So here, there is no problem, but there is a problem in that 2p and 3s. Least energy, he said, but they are having equal energy. What should I do? So in this case, he suggested us to take N plus L values in the increasing order. In the increasing order. So they are in the increasing order only. No. They are not in the increasing order. So first what we will take here, least N plus L value, that is 1s. Okay, take it. Next, I'll go for least N plus L value, 2s. Next, 2p equal 3p, 3s also equal. So I'm taking that. Okay. Next, 3p. Next, 4 is there. So 4s I will take. Next, 5, 3d I will take. Next, I will take 4p. Next, 4d. Next, 4s. Okay. So according to him, I arranged in the increasing order. But there again, the problem is there. There again, problem is there in 2p and 3d here. Sorry, 2p and 3s here. Because they are with the same N plus L values. 3 and 3. So which is lowest? So in this case, he suggested us to take according to N value, least N value will be first, filled with first. Right? So I'll make it clear here. Then only you are able to look at. Okay, look at here. So energy is calculated N plus L values. According to that, arranged in the increasing order. Okay, I raised a problem that is here. They are with the same values, N plus L. So in such case, same value, go for the least N value first. So in 2p, 2s, 2p, there is no problem. 2p and 3s, we are getting problem. So according to that, N plus L. So 2 plus 1, 3 I'm getting here. 2 plus 0, I'm getting 3 here. So in this case, what to do? least n value will be filled first. So 2p is first, 3s is next. So I got energies. 1s is least, 2s is least, comparing with the other. The next 3s is, 2p is least. Next 3s is least. So this method we are arranging. So according to that, the general order of increasing order of orbitals is here taken like this. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, right? So like this, I arranged. Is there any confusion in this? Give me a quick reaction. How I arranged? Fast, time completed. Go to quick reaction. How I arranged in the increasing order. So, Abhinay, there is confusion, I think. Are you in
Sir, no,
confusion?
sir.
No confusion. Okay.
Sir, no.
So we'll discuss in the next meeting. Immediately join.